Hello everyone and welcome to Module 3 Video 1 Introduction to DApps. My name is Sanchit and today I'll be guiding you through the fundamental concept and architecture of DApps. By the end of this session, you will have a comprehensive understanding of what DApps are, how they function, and their significance in the blockchain ecosystem. In this video, we will explore the underlying technology that powers DApps, how they differ from traditional applications, and the real-world problems they solve. We'll also discuss the benefits and challenges associated with DApps. So what are DApps? Let's start by defining them. They are an application run on a decentralized network, typically a blockchain, rather than a centralized server. This means they are designed to be transparent, secure, and resistant to censorship. Unlike traditional applications, they are controlled by a single entity. DApps operate in a decentralized manner, making them more democratic and open. To understand the concept better, consider how traditional applications work. For an instant, take an example of Facebook and Google. They are controlled by a single company that manages the server database. The central control can lead to an issue like data breaches, censorship, and single point of failure. In contrast, DApps leverage blockchain technology to distribute the control and data across a network of nodes. This decentralized approach eliminates the need for a middleman, reduces the risk of single point failure, and enhances the security and trust. DApps have several key characteristics that distinguish them from traditional applications. Firstly, they are decentralized, meaning they operate on a blockchain network with no single point of control. This decentralization ensures that no single entity can alter or manipulate the application without consensus from the network. Secondly, this is open source, which means their code is available to the public. This promotes transparency as anyone can review, audit, and contribute to the code. Open source development encourages collaboration and innovation, leading to more robust and secure applications. Thirdly, DApps are incentivized, often through tokens or rewards. These incentives encourage user and developer participation during the growth and adoption of the application. Users may earn tokens for contributing resources or completing tasks, while developers can reward it improving the application. Lastly, they use blockchain consensus mechanisms such as proof of work or proof of stake to validate transactions. These mechanisms ensures that all transactions are verified and agreed upon by the network participants, maintaining the integrity and security of the blockchain. A typical DApp consists of three main components: the smart contract, the front end, and libraries like web3.js or ethers.js. Let's break this down. Smart contracts are self-executing contracts with the terms of agreement directly written into code. They automate processes and enforce rules without the need of intermediaries. For example, a smart contract can automatically release funds when certain conditions are met, ensuring trust and efficiency in transactions. The front end is the user interface that interacts with the smart contracts, making the application user friendly. It could be a web application, mobile app, or any other interface that allows user to interact with the DM. The front end communicates with the smart contracts using libraries like web3.js or ethers.js, which bridge the gap between the user interface and the blockchain. Web3.js and ethers.js are JavaScript libraries that enable developers to interact with the Ethereum blockchain. They provide functions to read and write data to the blockchain, manage user accounts, and handle transactions. These libraries are essential for building decentralized applications that are both functional and user friendly. DApps offer several advantages. Firstly, they provide transparency as all transactions and changes are recorded on the blockchain and are visible to everyone. This transparency builds trust among users as they can verify all activities and ensure that the applications behave as expected. Secondly, DApps are more secure due to the decentralized nature and cryptographic security of the blockchain, making them resistant to attacks. Traditional applications often suffer from data breaches and hacking attempts, but DApps distribute data across multiple nodes, reducing the risk of single point of failure. Thirdly, DApps offer censorship resistance. No central authority can censor or control the application, ensuring that users can access and use the application without restrictions. This is particularly important in regions with strict internet regulation, as DApp provide an open and free platform for communication and transactions. Additionally, users have more control over their data and transactions, enhancing privacy and autonomy. To give you a better idea of DApps in action, let's look at some popular examples. Uniswap is a decentralized exchange for trading cryptocurrencies, allowing users to trade directly without a central intermediary. Uniswap uses smart contracts to automate the trading process, providing liquidity and facilitating peer-to-peer transactions. CryptoKitties is a blockchain-based game where players can collect and breed digital cats. This game showcases the fun and interactive potential of DApps, as each CryptoKitty is a unique, non-fungible token (NFT) stored on the blockchain. Players can buy, sell, and trade their CryptoKitties, creating a vibrant digital marketplace. MakerDAO is a decentralized finance platform that allows users to create and manage stablecoins. MakerDAO's stablecoin DAI is pegged to the US dollar and is governed by smart contracts. These examples highlight the diverse applications of DApp from finance and trading to gaming and entertainment. They demonstrate how DApps can revolutionize various industries by providing decentralized, transparent, and secure solutions. Now let's discuss setting up the development environment for creating DApps. The first step is to install Node.js and npm, which are essential for developing DApps. Node.js is a JavaScript runtime that allows you to run JavaScript code on your computer, while npm is a package manager that helps you install and manage libraries and dependencies. Next, install Truffle, a popular development framework for Ethereum-based DApps, by running the command npm install -g truffle. Truffle provides a suite of tools for developing, testing, and deploying smart contracts, making it easier to build and manage DApps. Finally, install Ganesh, a local Ethereum blockchain for testing and development, by running the command npm install g ganesh cli. Ganesh simulates a blockchain network on your computer, allowing you to test your DApp in a controlled environment before deploying it to the main Ethereum network. Let's write a simple DApp that allows user to store and retrieve a message on the blockchain. The smart contract will handle the backend logic and state management, storing the message on the blockchain. The frontend will provide a user-friendly interface for interacting with the smart contract. Integrating Web3.js will enable the frontend to communicate with the smart contract, sending and receiving data from the blockchain. Think of writing a simple DApp like building a basic vending machine that lets user input a message and retrieve it later. Here is a basic example of smart contract written in Solidity, which is used to store and retrieve a message. The contract has two functions: set message to store the message and get message to retrieve the message. Here, Pragma Solidity 0.8.0 shows the version, and all it is compatible with all the version above this. The contract holds the data of the message. It acts like a string, and the function setMessage will allow the user to store a message on the blockchain, while the getMessage function retrieves the stored message. To deploy the smart contract, we'll use a deployment script. This script uses Truffle to deploy the message contract to the blockchain. By running this script, we can easily deploy a smart contract to any Ethereum network, making it accessible for interaction. The deployment script specifies the contract to deploy and the network to deploy it on. Truffle provides a migration system to manage deployments, ensuring that each step is recorded and can be rolled back if needed. Deploying smart contract is a crucial step in development, as it makes the contract available on the blockchain for user to interact with. The front end consists of simple HTML interface that allows user to set and get messages. It includes input fields and buttons from interacting with the smart contracts. This interface ensures that user can easily interact with the smart contract without needing to understand the underlying blockchain technology. The HTML code defines the structure and layout of the interface, providing a user-friendly experience. The JavaScript code handles the interaction between the frontend and the smart contract. It uses Web3.js to communicate with the Ethereum blockchain, enabling functions like setting and getting messages. The JavaScript code connects to the blockchain, retrieves the contract instance, and calls the contract functions based on user interactions. It also handles user account and transaction, ensuring a seamless integration with the blockchain. Here, it uses some constants and uses a local host for this, and later two functions are defined, one for set message and another for get message. To deploy and integrate with the DApp, follow these steps. Start Ganesh, compile the contracts using Truffle, deploy the contracts to development network, and open the frontend in a web browser. Starting Ganesh simulates a local blockchain network, providing a sandbox environment for testing and development. Compiling the contracts ensures that they are correctly translated into bytecode that are deployed on the blockchain. Deploying the contracts to the development network makes them accessible for the interaction, and opening the frontend in a web browser allows user to interact with the DApp. Interacting the DApp is like setting up and using a vending machine in your workshop. You start the local blockchain, compile and deploy the contracts, and then interact with the DApp through the web interface. To summarize, DApps are decentralized applications that run on blockchain network. They have key characteristics such as decentralization, open source nature, incentivization, and consensus mechanism. We discussed the components of DApp including smart contract frontend and libraries. These components work together to create a decentralized, transparent, and secure application. DApps offer advantages like transparency, security, censorship resistance, and user control. These benefits make DApp an activate alternative to traditional applications. Then we saw some example of the DApps ranging from gaming, finance to other sectors. And then we saw how to set up the environment to create a simple DApp which would be used by a user to set and get messages. Finally, let's conclude with an interactive exercise and quiz. This will cover defining what a DApp is, listing its key characteristics, providing example of popular DApps, setting up a development environment, writing a simple contract, developing a front end to interact with the smart contract, and deploying the contract to a local blockchain. By completing these tasks, you'll gain hands-on experience with building a decentralized application and a better understanding of key components and development process for DApps. These exercises will reinforce your knowledge and skill, helping you to become proficient in DApp development. Thank you for watching this video. Hope it helped.